In this video, I would like to finish up our section 1.4 talking about decomposing functions this time. So when we talk about decomposing, not starting off too well, huh? We'll go again. When we start up talking about decomposing, seems like there should be a joke there, but it's kind of leaving me right now. All right, decomposing is going to be reversing the process of doing the composition. Okay, so this time we're going to have a function h of x. And h of x is going to have been the result of doing f times g of x. So the name of this game is, if you want to call it a game, a quick little highlight, is that we want to see what an h of x looks like and see if we can figure out where did it come from. What are the two functions that were composed doing a composition to get to the h of x? All right, let's do a couple of examples here. Okay, so let's suppose that we have an h of x and it equals the square root of x to the third plus 1. Okay, so we want to see if we can break that down into an f of x and a g of x, such that f of g of x gives us that function. Okay, maybe thinking of parent functions is helpful here. Okay, like your very basic functions, your linears, your square root, your squares, that sort of thing. Okay, so in this case, let's suppose I came up with f of x is the square root of x. So if that's the case, then g of x would have to be the x to the third plus 1. The idea being, if you do f of g of x, we get h of x. Okay, so in other words, if we take this x cubed plus 1, substitute it in up here for x, sure enough, we're going to end up with the square root of x to the third plus 1. Okay, let's go again. Sometimes it takes a couple of examples to catch on here. All right, so let's try h of x equals 5x minus 4. Okay, and again, let's think about what could we figure out here for f of x and g of x. In a way, it's like a puzzle. You have to decompose to come up with this answer. Okay, well, let's think here. What if we make f of x x minus 4, g of x could be 5x. So the idea again, if you do f of g of x, so g of x would substitute in here for the x, and sure enough, you would get 5x minus 4, and it works. Okay, all right, let's take a look here at another one. Let's say h of x equals 1 over x squared plus 1. Okay, and let's think about how we're going to pull that one apart. F of x and g of x. So we want g of x to plug in. Well, let's go to basic. Okay, kind of like the parent function idea. 1 over x. All right, so there's your basic 1 over x. So what are we going to replace x with? Well, it would be x squared plus 1. So if you take that g of x, all of that, and substitute it in, you end up with 1 over x squared plus 1. And sure enough, that one works. Okay, I'd say we're on a roll here. Okay, let me see if we have maybe another one or two here that we could take a look at. Gosh, how about, we'll do one more here. And like I said, it takes a little bit of practice to catch on to this. All right, let's say h of x equals x minus 3, the quantity cubed, plus 2, x minus 3, the quantity squared, plus 1. Okay, so we got to think about how we're going to break this one apart. Okay, so we need an f of x and a g of x. Okay, well, something I personally notice is that we have some commonality here. All right, well, what if we went ahead here and we make g of x be just that x minus 3 character? Okay, then if you're thinking along with me, if we pull that out, then it would leave an x to the third plus 2x squared plus 1. So again, then the idea is this x minus 3 would substitute into both of those. Places for x, and we would end up with our h of x. Okay, sorry about that. Get a phone call in the middle of a video. What are you supposed to do? Can't stop decomposing just to answer the phone. Who would ever do that? All right, so there's some examples for you with decompositions. Last thought here, before I leave you with section 1.4, we have the word relation. Okay, and we know that a relation is a set of ordered pairs. Okay, whenever we have a relation, it's a set of ordered pairs. Okay, so maybe I would give you a problem like this. Determine which ordered pairs are in the relation given by x, y, plus y squared equals 5. Okay, and I'll give you some ordered pairs over here to try, like 2, -5, 1, 3, and 2, 1. Okay, so which of those ordered pairs are in this particular relation? Okay, so what we'll do is we'll substitute in our values into the relation and see which ones work or satisfy the equation. So in the first case here, we would do, actually, you know what, I miswrote that, my bad. Okay, let's make this x squared y plus y squared. There we go. Let's give that a try. Okay, so we would do here 2 squared times -5 plus -5 squared, and we want to know, does that in fact equal 5? Well, 4 times -5, okay, I'm going to run out of space here, but 4 times -5 is -20, plus 25, sure enough, that one equals 5, okay, so 2 -5 works. All right, then we'll go again. Okay, so next one, let's try 1 squared times 3, times 3, plus 3 squared. Does that one equal 5? Well, this case, we're going to come up with 3 plus 9. Well, guess what? That does not equal 5. So this one does not work. All right, so then we'll go again. This next one, we would do 2 squared times 1 plus 1 squared. Does that one equal 5? Well, 4 plus 1, sure enough, equals 5. So that one does in fact work. So in summary, we would say determine which ordered pairs are in the relation. Our answer would be 2, -5, and 2, 1. Those are in the relation. Are in the relation. They satisfy the given equation. Okay, I hope that's helpful for you. I'm sure it's going to take you a little practice to get the decomposition, but hang in there. As long as you're above 6 feet above the ground, you're in good shape. Okay, good luck with decomposing.